moves in all directions, spontaneous emission, and so some of the atom will be reduced. Say roughly at room temperature, the reduction of momentum is about 3 centimeter per second. 3 centimeter per collision. So that is the basis known as Doppler's coupling. Next page. Using two techniques, Doppler effect and Zeeman effect, and then measurement of temperature and some information about feed. Now you will just realize not only to cool atoms but also to raise its temperature to a very high level, to a temperature 10 to the power 8 Kelvin. That means the temperature that you find at the core of the sun. So there are two situations where you can use laser for raising temperature to a very high level, and to a situation is 10 to the power minus 6 Kelvin, whether minus 3 Kelvin. Zeeman effect is further 9 Kelvin. Next page. Now this is frequency given by the expression nu equal to nu naught 1 plus V by C, and thus there is change in energy. For that energy, it is the kinetic energy which is useful here in increasing the frequency of the incident laser. Next page. There should be matching of energy, and that matching is obtained by increasing the frequency of the incident laser, the frequency of the laser beam. So this is the change in loss of momentum. This is loss of momentum m into delta mu. This is delta v. So delta v, and so delta v, what you manage, you have sodium atoms and you engage laser beams from all 6 directions, having frequency slightly less than the required frequency of absorption. Now since atoms are going to see the frequency increase, they lose energy by emitting photons. Next page. You are sending a photon having less amount of energy, but the atom will require specific energy so that absorption can take place. Now this is the energy of the incident photon. This E1 is the level of energy of an atom. So atom cannot absorb this photon. Atoms are highly selective, they cannot absorb this photon. One way that we discussed earlier, incident photon is increased, and so atoms can absorb energy. The other approach is that we can lower down the energy level of atom from E1 to this level. As the energy level is stored, so the atom will go to the higher energy level, and the difference of energy will be again compensated by the fact that the photon is absorbed at a lower frequency h nu naught, and emission takes place at a higher frequency h nu. So there is difference of energy, and that difference is being used from kinetic energy of the atom, and so the atom is losing its kinetic energy, and so it cools down.